Hello everyone. Today we are going to give an overview of the topic software security, whose responsibility. We are the team of 3 engineers. I'm Sudipta Devnath, followed by my fellow colleagues Prapti and Rajiv are going to take you through this journey. Now, being said that, what we are going to cover in today's agenda is what is software security, whose responsibility it is, like architect, developer or DevOps, and finally a conclusion on the topic. So a secure system is one that does what it is supposed to do. What does it mean? That means software security is an idea implemented to protect software against malicious attack and other potential hacker risk so that software continues to function correctly under such potential risk. Why the software security is important? Because security defines the dimensions of software assurance, and it also identifies the threats that target most software and the shortcomings of the software development process. Now, being said that, what is the architect responsibility as part of the software security? Every software is a mission critical asset. So prevention, the design of the software, and operations are 3 key parts of the layer security architecture. Now, being said that, when an architect is going to design the software, he has to adopt a 4-stage adaptive security structure. Predict what is the risk, design the system to prevent the risk, detect the risk, respond to the risk, and this is a dynamic process which should move across all the project life cycle. Now, being said that, I will pass the session to Prapti to take you through the developer responsibility in case of software security.
Thank you. So let's have a look at what software security means for a developer and how we can implement it. The current flawed approach is when functionality is given a higher priority as compared to security. A better approach would be to build in the security right from the beginning. We need to incorporate a security-minded thinking into all phases of development. Next. Let us see how we can incorporate the security in software development lifecycle. The software development lifecycle consists of requirement, design, implementation, and testing. Let us start with requirements. A security requirement needs to be added right from the beginning. These requirements define the security expectations of a software operation. How can we enforce these requirements? We can enforce them by defining abuse cases. What is an abuse case? Define what a software should not do. It can be identified by looking at patterns from likely attacks which can break a security requirement. Next. Design and implementation. What is a software defect? A software that behaves incorrectly or fails to meet the requirement. A bug is a defect in implementation. A flaw is a defect in the design. Our aim to ensure security is that we must eliminate bugs, design flaws, and make them harder to exploit. Next. The principles for secure designing. First, favor simplicity. It is so simple that it is correct and secure. First, use fail-safe defaults. For example, the length of cryptographic keys is 2048 by default. Whitelisting instead of blacklisting. Do not expect expert users. The natural or the obvious choice is the secure one. Do not have users make frequent security choices. Help users explore ramifications of their choice. Second, trust with reluctance. Employ a small trusted computing base. Grant the least privileges possible. Look at the open source components. Make sure they do not contain vulnerabilities. Compartmentalize. Isolate a system's component in compartments, reducing its privilege by making certain interactions impossible. Promote privacy. Defense in depth. Security by diversity. Not relying on a single kind of defense such that if one defense is overcome, there is still one that needs to be bypassed. Use community resource. This is a tricky one as we need to use the community resource, but make sure there is a hardened code. For example, crypto libraries that are used from other projects. They should not be trusted right out of the box. They need to be tested to make sure they meet our requirements. Vet design publicly. The code is put out to the fellow coders to comment and find out loopholes. Stay up on recent threads. Last, monitoring and traceability. Design systems should firstly allow us to determine when an attack has taken place and secondly, how the attack succeeded. To satisfy this, we need to have the system log relevant operational information like events handled, packets processed, and requests satisfied, etc. Log aggregation. Correlate the activities of multiple applications when diagnosing a breach. Now, I would like to pass it on to Rajiv to continue further.
Thank you, Prapti. So I'm going to be talking about security in a DevOps environment. DevOps is a set of philosophies, practices, and tools that help an organization deliver better products faster by blending two traditionally separate functions, development and operations. A DevOps model shortens the development lifecycle and provides continuous delivery with high quality using continuous integration and continuous delivery methods, which are often referred to as CI/CD. Next slide, please. Now here is how a typical CI/CD pipeline looks like. The orange blocks represent continuous integration stages, and the blue blocks represent continuous delivery stages. Automation is fundamental to CI/CD pipeline, and various types of testing can be performed throughout the pipeline. One problem that is typically seen in a DevOps pipeline is that security is often ignored or applied very late in the development lifecycle. Security is often done by a separate team, and developers don't want to slow down for security checks and requests. As a result, security vulnerabilities go undetected or are detected in production at the end of development lifecycle, causing significant delays in the release. Next slide, please. To solve this problem, organizations are getting security embedded into every stage of DevOps lifecycle by adopting DevSecOps. DevSecOps extends the concept behind DevOps and advocates that security should be built into the product rather than applied to a finished product. It is often achieved by shifting security left or earlier in the software development lifecycle. The existing CI/CD pipelines are leveraged to include automated security checks for code analysis, security vulnerabilities, threat monitoring, compliance, etc. So as can be seen here in this CI/CD pipeline, security has been integrated and several different security tools, processes, and policies are added to facilitate rapid and secure releases. Next slide, please. Now I'm going to reiterate some of the best practices that Prapti earlier talked about and how these can be used to integrate security in a CI/CD pipeline. Number one, create security user stories. Security can be built into software during design and build phases. The product owner, security architect, and engineering team should brainstorm and identify the security user stories specific to the application being built. Each story can be specific to a vulnerability to be addressed. Number two, use the right tools. It is important to be selective when choosing tools for security testing. The goal is to fix issues and to not overload engineers with too many tools or alien processes. These tools must adhere to the following principles. Tools must be integrated into the CI/CD pipeline. Tools must not require security expertise from developers. And tools must work fast and must avoid reporting high false positive issues. Number three, continuous security testing using automation. Security should be applied continuously throughout the entire CI/CD pipeline using automation. Source code changes must be checked with static analysis tools prior to commit to the main branch. Security testing must be performed to scan third-party components for known security vulnerabilities. If containers are used in your service or application, base images must be scanned for known vulnerabilities. And finally, continuous delivery and monitoring. After the application has been deployed to staging or production environment, runtime security and compliance checks should be triggered to ensure that only the necessary services are enabled, only the needed ports are opened, permissions on files, audit and logging policies are enforced, and development tools are not installed on production servers. Continuous monitoring can identify potential weakness in the system, and the team can fix these before the application gets deployed to production. Now I will pass it back to Sudipta for providing concluding remarks.
Security is everyone's responsibility. In a software lifecycle, understanding the necessity of the security is very important. Security is a culture which must be implemented as part of process at organization level. It needs to be integrated every stage of the software lifecycle management, not at the end. Security is every stakeholder's responsibility, necessity to implement at every stage. Thanks the organization committee to give us the opportunity in the SecCon APJC. Thank you.